Hey everyone, today we'll be going over acid and base definitions. Okay, so I think we all have a good idea of what an acid and what a base is already. We all know that acids have a pH lower than 7, and we all know that bases have a pH higher than 7. We also know that acids taste sour, while bases taste bitter. But for the AP exam, we're going to need to learn some more technical definitions, and here are the three ones we need to know really, and each of them are used for different things and have different purposes. So let's get this thing started. Okay, so Arrhenius has the most specific definitions of acids and bases. According to him, an acid is a substance that ionizes in water to produce H plus ions. So the classic example would be hydrochloric acid, which is HCl. And we know that's going to dissolve into H plus and Cl minus. So we know hydrochloric acid is an acid because it produces H plus ions. Likewise, bases are substances that ionize in water to produce hydroxide ions. So the classic example would be sodium hydroxide, which dissolves into sodium ion and hydroxide ion. So yeah, we know sodium hydroxide is a base because it ionizes in water to produce hydroxide ions. So yeah, this is probably the most well-known definition of an acid and base, but we need to learn two more. Okay, so Bronsted and Lowry have a broader definition of acids and bases. According to this theory, an acid is a substance that can donate a proton or an H plus ion, they're the same thing, and a base is a substance that can accept a proton. So I'll give you an example to demonstrate what exactly this theory is saying. So let's say we have this. I'm just going to write it down really quick. So I'm just going to give you this chemical equation, and we'll identify what, is the acid and what is the base. Okay, so according to the Bronsted-Lowry definition of an acid, what is the acid in this equation? Well, an acid is a substance that can donate an H plus ion. So which of these substances looks like... which substance looks like that it can donate an H plus ion? Well, that's obviously going to be this one over here, because we see that it loses an H plus ion when it becomes a product. So, yeah, so we know that this is going to be an acid, and this is actually called acetic acid, and it'll be showing up a lot. It's a very common weak acid. So, what is the base in this situation? Well, a base accepts protons. Well, let's look here. Then look at this H2. Look at this water molecule. It starts as H2O, right? Then look on the product side. It gains, a hydrogen ion. So this is so we know that the water is going to act as a base. Okay. So what about the products? Can they be called acids and bases as well? And the answer is yes. So let's look here. Look at this acetate ion right here. It doesn't have an hydrogen ion. It wants to receive a hydrogen ion. So it doesn't want to. That's bad language. But it can accept a hydrogen ion. So that's why we can call it a base. So yeah, you can call it a base. And there's actually a specific name for it. It's called a conjugate base. And the acetic acid and the acetate ion, they make a conjugate pair. A conjugate pair. And likewise, the H3O is the water's conjugate acid. conjugate acid. And they also make a conjugate pair. And yeah, there'll be a lot of multiple choice questions just asking you, what is this substance's conjugate pair? I mean, conjugate acid or conjugate base, and you'll have to answer that. I'll give you guys another example. Let's say we have some ammonia in water. NH4 plus, and we have our hydroxide. Okay, so yeah, this is a little more different. This is actually a little more difficult because we don't have the H, in front of the, acid to know that it's an acid. Well, I'll give you guys a moment to think. Well, let's first ask ourselves, what can donate a proton? Okay, what is donating a proton? And from the looks of it, it looks like it's the H2O molecule, because look, it starts off as H2O, but then it goes to OH minus. It lost an H plus ion, so we know that this is going to be the acid. And what's going to be the base? Well, the base is what receives the H plus ion. And look at this NH3. It starts off as H3, but then it becomes NH4. So we know that this is going to be the base. And yeah, and just like before, we know that this is going to be the conjugate base. And these guys are going to be a pair. And we know that this is going to be the We know that this is going to be the conjugate acid. So these guys are going to be together. Okay, here is our last acid-base definition. It's by Lewis, and this is the most broad one. It says an acid is simply an electron pair acceptor, while a base is an electron pair donor. Okay, so let's think this through. So I'm just going to give you guys an example of a chemical reaction and see what you guys think. We have, let's say we react ammonia, and with BCl3, or what is that? Boron trichloride, and we're gonna get H3 and BCl3. Okay, so what is the acid and what is the base? Well, let's draw the chemical structure of these molecules. So NH3, it's gonna look like this. It's gonna have an unpaired, it's gonna have an unbonded electron pair, and then it's gonna look like this. And the BCl3, well, it's gonna look like this. So now that we have the structures, let's predict what's going to happen. Well, look, the NH3 has an electron pair to donate. It's just hanging on the molecule. And the BCl3, well, it has space to accept an electron pair. So we know that the NH3 is going to be the base once again, as it usually is. And we know that the BCl3 is going to be the acid because it can accept an electron pair. And yeah, so this is the broadest definition of a acid and base. And yeah, so I hope you like this video. And next time we're going to go over how to calculate the pHs of acids and bases. So yeah, have a good night and goodbye.